Welcome back. So in this section, I want to cover certain conditions that make a function a function. What do I mean by that? I want you to remember the very first example that we had on airplanes. Do you remember we had this function where we had time, and then we had distance, and then we had this function and then distance dependent on time like this, d equals 800 t. But let me ask you a question now. What if I have a function like this? So I have time here and I have distance here, and my graph is something like this. Does this function make sense? Well, no, it wouldn't make sense, because essentially what you're saying is that at time equals, let's say, 2 hours, the airplane has covered this distance, which is, I don't know, 1 kilometer, then also this distance, which is 4 kilometers, for example, I'm just throwing out numbers, and this distance, which is 6 kilometers. Now, it's impossible for the airplane in 2 hours to cover 1, 4, and 6 kilometers. And in fact, if you generalize it in the world of functions, then something like that cannot be a function. There's something called a vertical line test, which means that you take a vertical line and you go over all the axes. So in this case it's t, but let's say in general it's x. We have x here and we have y here. And then you take this vertical line and you go over all the axes from minus infinity to infinity. And the rule is that this vertical line needs to touch the graph only once. So if you have a graph something like this, and then you take this vertical line test, and if you go over all the axes, the graph will always touch the line only once. Then it's a function. But in this case, it's not a function. Notice, however, that if I have a function like this, let's say this line, it's okay if many x's go to y. What do I mean by that? So if I take a random y value here, let's say y equals 2, and I draw a horizontal line like this and like this, then you can see that this horizontal line cuts here, 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 and here. That means that many x's, let's say x1, x2, and then x3 and x4, many x's are mapped to that one y, which is y equals 2. So a situation like that is okay. So something like that is okay. But something like that where one x is mapped to many y's, this is not okay. This is not a function. Another way to look at it is like this. I'm going to introduce two new terms. One is domain. What is domain? Domain is all the possible x values, or all the possible input values that you can have, all the possible independent values. So if I just say that this is a bag of all the possible inputs that I can have, and then another term would be range. Range is all the possible outputs, or in our case y's, that you can have. And let's say that you have certain y's here. Now, for some functions, the domain would be from minus infinity to plus infinity. Like, for example, with a function like y equals x. So you would have something like this. You would have a graph, and this graph would go from minus infinity to plus infinity. And also y would go from minus infinity to plus infinity because there is no reason that this graph would stop. In this case, you would say that domain goes from minus infinity to plus infinity. However, in our airplane example, our function was restricted because we started at time equals 0. We did not measure what was before time equals 0. So our function started from here. So our domain would be from 0 to plus infinity. So that would be our domain. And our range, the distance, so in this case domain would be all the possible times and range would be all the possible distances. It would also vary from 0 to plus infinity. And by the way, when we have this bracket, then that means included. That means 0 is included. A parenthesis means not included. So infinity nor minus infinity, they are never included. If I had written like this, 0 to plus infinity, then the function would look something like this. I would have an empty spot at t equals 0, and then I would have a function like this. So brackets included, parentheses not included. So in a function you can map multiple domain values into one range value. So you can map this one here. You can also take another domain value and map it to the same place and the same place. So that is a function. Now what is not a function is if you again say that this is a domain and range, and then you take one domain value or one x value and you map it to one range value and then you map it to another range value. So this is a general way to look at it. So this would be a function, this would not be a function, because this picture would represent something like this. Or in fact, you probably all remember that there is a circle function. So a circle is represented radius squared equals x squared plus y squared. Even though you can represent it like that graphically, it's not a function, because if you apply the vertical line test, you can see that it cuts the graph in two places, which means that it's not a function. Now, in the section where we discussed whether some kind of graph is a function or not, we also briefly touched upon on the equation circle. So we had a circle, and that would be the graph. And the equation of the circle was r squared equals x squared plus y squared, right? So this is x here, and this is y. And that also comes from the Pythagorean theorem. That's because, let's say if you draw a radius here, then you would have some kind of y here, and then you would have some kind of x here, and you would get this radius, this one, using a Pythagorean theorem, which is the same thing. You would take this x squared and you would add y squared, and then you would get this quantity squared. So radius would be square root of x squared plus y squared. So that also came from the triangle, right? So you had x and y here, and that's how you would get r. However, we also discussed that this graph cannot be a function, because if you apply the vertical line test, you see that the vertical line touches this graph in two places, and therefore it doesn't qualify to being a function. However, What you can do, you can take that circle and you can divide it into two. You can choose two sides. You can either choose the lower side or the upper side. Let's first see the upper side. So I'm going to draw a function now. X, Y. Well, first of all, I'm going to assume that the radius equals 1. Let's say 1 meter. And then I can draw a circle here. Well, it's half of the circle. And the function of this half of the circle would be y equals square root r squared minus x squared. So how do I get it? Well, I get it from this equation. So r squared equals x squared plus y squared. If I want to get y, then what I do is this: y squared equals r squared, and then x squared goes to the other side, so it's minus x squared, and then I just take the square root of it and I get y. So this equation, it represents this graph, and if radius is 1, then this is 1, this is minus 1, and y here at x equals 0, y equals 1, which makes sense because the radius is 1. So if the radius is here, x is 1. If the radius points in this way, it's minus 1. If the radius goes up, then x equals 0 and y equals 1. Let's just take an example. If x equals 0, then y equals 1 squared minus 0 squared, and you would get square root of 1 squared, which is 1. So that's one way how you can represent a circle. You would just take one part of the circle, the upper part. However, if you want to represent the other half, then it's very easy. What you do is very simply, let's say all the conditions are the same. What you do, you simply put a minus sign in front of the original function. Y equals minus square root r squared minus x squared. That's how you can represent the entire circle as a function. You just choose either one side or another side. You either choose the upper side and you use this equation, or you choose the lower side and then you choose this equation. Let's say a good way to understand why this graph will become this graph if you put a minus sign in front of it is like that. So if you draw the upper circle, but instead of a line, you just imagine that there are a lot of points here. Well, if I put a minus in front, and that means that I put minus 1 in front of this function, and I multiply minus 1 by this function, if I do that, then all these points, they will be mirrored about the x-axis. So this point will be mirrored here, this point will be mirrored here, this point will be mirrored here, this point will be mirrored here. If this is like 0.25, then it has to be minus 0.25 here, because I simply multiply this number by minus 1. And that's how you can get the lower circle. Alright, there's one more thing I want to cover, and that is the inverse of a cubic function. So I have a parabola here, and I want to take an inverse of that parabola. So what do? So I take y old axis and I put it here, and I rename it x new. And then I take the x old axis and I put it up like this, and I recall it y new. Okay, so if we go on this y old axis, if we go up by 1, then what do we get? Well, we get 1 and minus 1. on the x old axis. So if we remap it, we should get something like this. 1 minus 1. And then if I go to 4, here, then it would be 2 here, and it would be minus 2 here. Because if on this old axis I go to 4, I need to go to 2 in order to get to the x old value. So essentially what just happened was that I took a square root of 4 and I got plus and minus 2. So if you go from 2, then you would get some kind of value here, which is around 1.4 something. It would be equivalent to square root of 2. And then for 3, you would also have square root of 3 somewhere here. So you would have a graph that would look something like this. And the same thing would be here. So that would be the inverse graph of this function. Now, it might be the inverse graph. However, is it a function? No, it's not. Because remember, we applied the vertical line test, and now it touches the graph in 2 places. So it cannot be the function. So that means that you have to choose the side that you want to work with. You either choose this side and you go from 0 to plus infinity. You choose your domain, and then if you choose this domain, then you get this graph. Or you choose this side, which means that you work from minus infinity to 0, and remember brackets are included. So you only take this part, and then you get this graph. Both choices are valid. However, if you have a calculator, most calculators are programmed to choose this side and this one. So that's why if you take a square root of 4 in a calculator, you usually get 2. But the reality is that both numbers are correct. So a calculator can also give you minus 2 and it would still be correct. So if you choose the upper function here, so you choose the domain from 0 to plus infinity, then your general function would be y equals square root of x. However, if you choose the other domain from minus infinity to 0, and then your inverse function would be this line here, then your function would be y equals minus square root of x. And by the way, remember that square root of x is the same like x to the power of 1/2. Remember? So 2 goes here, and 1 is the exponent of x. So for example, if I have x to the power of 5/3, then it's the same if I write it like this. So 3 goes here, and I put it here, and then 5 goes here. So just a reminder. Now, another important part that I want to emphasize is this. So if you have a parabolic function and you take the inverse of it, and then the inverse, as we saw before, can be either like this or it can be like this, then notice one thing. When you take the inverse, you never reach the negative values for y old or x new for that matter. You never reach this part, right? So you have the positive parts, but you don't have the negative parts. So you never reach it. And that's why when you put minus 4 into a calculator, it gives you an error. In fact, if you take minus 4 here, and you move here, where you have minus 4, then there is nothing here. Absolutely nothing.